All right, good morning. Just going back to looking at what we have regarding the characteristics of a function. And we left off last time with taking what we have had with in behavior. And again, so we have for a polynomial, okay, if the coefficient of the highest degree term is positive and the degree of the highest order term happens to be odd, okay, the end behavior have down to the left and up to the right. And if the leading coefficient is negative while the degree is odd, okay, you have the polar opposite behavior where we have up to the left and down to the right. And in the case where we have even degree functions, okay, if the highest order term has a positive coefficient, then you have the end behavior to be up to the left and also up to the right. And if the coefficient is negative, then we have once again the end behavior is down to the left and down to the right. And for what we have, again, I had mentioned an item the other week, and this was number of turning points. Okay, and just kind of going back to this right quickly. And just tying it together with what we have with in behavior. Okay, so you have all these items like the zeros, multiplicities, in behaviors, and now we have with turning points, and again we have the number of turning points. Okay, I have a polynomial function f of x. Okay, it's going to be at most. One less than the degree of f of x. And another way of saying this, okay, is that the degree of f of x will be at least one more than the number of turning points. Okay, and just looking at what we have here. Okay, say we take as an example. Okay, so if you were to determine I'm going to give you a graph in just a moment. Okay, so you're looking at the sign of A of n. The number of turning points. and the possible degrees of f of x. Okay, so we have, let's see if I insert, okay, so again we have in the xy coordinate system. Okay, and if you notice, okay, we have with the, just starting out, okay, we have, say we were to count the number of turning points. Again, those are going to be your combined relative minimum and maximum. Okay, and we have regarding, say for the end behavior, okay, to the extreme left, okay, we have moving down to the left, and to the right we have moving upward. Okay, so again we have with the end behavior, okay, so you have down to the left, and up to the right. Okay, and just okay, now for the parts here for the sign of a of n. Okay, remember, it's kind of going back to what we have in the chart. So you have down to the left and up to the right, and this will occur if the degree is odd, and also where a of n is going to be positive. Okay, so we have with this end behavior, okay, so things here, a of n is positive, and we're going to have that the degree is going to be odd. Okay, and once again for the combined number of relative maxima and minima, okay, we have 4, so we're going to have 4 turning points. And again, we had that the degree n is odd. And since this function has 4 turning points, now, again, the number of turning points is always going to be less than the degree, and the degree is odd. So possible values of n is going to be at least 5. Or it could be 7. Or any other increasing odd power. Okay, but n is going to be an odd number, and again, it's going to be at least 5. So if you were to say that, you'll be correct to say n is odd and a of n is positive. But looking at the number of turning points, you cannot say that among the odd values you're going to have 1 or 3, because again, the degree has to be more than the number of turning points that will exist. Okay, now let's say that if we have as another case, All right, now for the end behavior that exists for this function. Okay, so have both down to the left and down to the right. And looking at what we have with the number of turning points. Okay, so again, you're combining the relative minima and maxima that will occur. Okay. And again, we have in repeating. Okay, so you have the end behavior. Okay, we have down to the left, down to the right. Okay, so for what we have here, you have the end behaviors down to the left and down to the right. Okay, this will be the last case where a of n is negative and n is going to be an even value. Okay, so a of n is negative. Okay, now for the number of turning points, again, that will amount to 7. Okay, so we already have the n is even. Okay, but again, among your even values, okay, in terms of what n cannot be 2, it cannot be 4, and it cannot be 6, because the degree cannot be less than the number of turning points. So we have, in this case, for what n could possibly be, okay, so not 2, 4, or 6, okay, so the minimum degree that n can possibly be is going to be 8. So you're looking at an even value that will be higher than the number of turning points. So it could be 8, it could be 10, or it could be some other higher even value, like 12 or 14. All right, so those are samples, okay, of what we have linking together in behavior as well as the number of turning points. All right, now just for what we have, kind of going back to the polynomials, okay, where we have on page 266. And we have, in the case of number 48, okay, so here we have an illustration. Okay, what we have with the polynomial function. Okay, and here we have locations of zeros. And we have with the graph. Okay, so you have for your in behavior. Okay, so this is going to be up to the left and up to the right. And just for what we have, again, for the zeros, okay, we have at -4, -1, and +3. And looking at the combined number of minimum and maximum. Okay, so you have 3 turning points. Okay, so just for what we have for starters, okay, so the end behavior, okay, we have to be up to the left and up to the right. Just going to reference here, up to the left and up to the right. So A of n is going to be positive and n is going to be an even value. Okay, so we have A of n is positive, and the degree n is an even value. And for what we have for the number of turning points, okay, so we have 3 turning points. And here the problem is asking for the minimum degree. Okay, so in this case, n is even, and the minimum value n is going to be greater than the number of turning points, so the minimum even value greater than 3 is going to be at 4. And just to restate, okay, for what we have in the case of part B, once again, A of n is positive on the basis of what we have with the n behaviors. Okay. Now, in determining the nature of the multiplicities of the zeros, okay, so just looking at what we have here. Okay, so you have with our zeros, okay, where they cross and touch the x-axis. Okay, so you have among the zeros, so you have x equal to -4. And we have x equal to -1. As well as x is equal to 3. Now for the behavior, okay, like in terms of crossing or touching, okay, so at -4, okay, the graph is crossing. -1 is also crossing. And at x is equal to 3, okay, so it is touching. And in terms of whether the respective zeros will have even or odd multiplicity, okay, and again, okay, for zeros of odd multiplicity, the graph is going to cross. For those of even multiplicity, okay, they will touch. Okay, so -4 is going to be of odd multiplicity. And we're going to have that -1 is also going to be of odd multiplicity. And 3, okay, since we have the graph to touch, okay, 3 is going to be of even multiplicity. So this is what we have, just looking at what we have along the visual parameters for what is entailed, okay, for the graph in problem 48. Now, in looking at what we have, taking what we have in the combined features, say if we look, say ahead, see we have on page 59, and we have a function f of x. Okay, and that is equal to x cubed minus 5x squared. Now for the mechanics involved, okay, so if we look at the end behavior first, okay, so the leading coefficient, okay, that is going to be at 1. Okay, so we have that a of n is equal to 1, okay, and that's going to be a positive value. And again, for the degree of this function, okay, we have, again, the highest order term is of degree 3. Okay, so we have 3 is going to be an odd value. So combining, okay, what we have, okay, so you have a positive leading coefficient and the degree is odd. And so this is going to mean that the end behavior is going to be down to the left and up to the right. All right, now just concerning what we have with the intercepts. Okay, so we have first of all, we have f of x equal to x cubed minus 5x squared okay, so if we look at factoring, so for x cubed minus 5x squared, okay, so we're going to have the greatest common factor will be at x squared, and taking into x cubed minus 5x squared, we have the quantity of x minus 5. And for what we have in the case of the zeros, okay, so you have two factors in the variable x. We had the letter x itself, and we have x minus 5. Okay, so you have a couple of zeros here. So from x, I have x equal to 0. And from x minus 5, okay, I have x is equal to 5. And for what we have in the case of the multiplicities, okay, so x minus 5 is not given to any explicit power, so you just read this as 1. Now we'll just color code the degrees in the factored form. Okay, so we have with x is equal to 0. Okay, so this stems from x, and not just x, but x to the second. Okay, so 0 is going to have a multiplicity of 2. And x equals 5, this just stems from x minus 5, not to any raised power, only just the number 1. So 5 is going to have a multiplicity of 1. And in terms of crossing or touching the x-axis, and again, any zeros with even multiplicity will be locations where the graph will touch the x-axis. So it's going to touch at x is equal to 0, and for x is equal to 5 with a multiplicity of 1, it's going to cross at x is equal to 5. Okay, and just adding one more item. Okay, this is going to be with the y-intercept. And again, f of x is a functional notation for what we otherwise say is going to be y. And for the y-intercept, we're looking at solving for y as x is set to 0. And guess what? We have x cubed is going to be 0 cubed. We have minus 5 times 0 squared. 0 cubed is 0. 0 squared is 0. So we had that y is equal to 0. So we have for the y-intercept, we have y is equal to 0. And placing in coordinate fashion, okay, that will be located at the origin. All right. And so just taking a sketch concerning the behavior of the graph of this function. Okay, so you have our zeros at 0 and 5. Okay, and the end behavior, okay, you have down to the left and up to the right. Okay, and for what we have regarding the in-between activity case, so the graph is going to touch at x is equal to 0, okay, and it is going to cross at x is equal to 5. So T for touch, C for cross. Okay, and so we have for the rest of the activity, okay, so you have touching at x equal to 0. So you have starting out, so you have the end behavior, you have down to the left. Okay, so as I move from left to right, the graph is underneath, and once we get to the x-axis at 0, it's going to touch or just bounce off. And then it's going to rise again, and once we get to x is equal to 5, okay, the graph is going to cross, and we have up to the right, and so this will be the behavior that we're going to have for this particular function, f of x. All right, now, and looking at what we have also regarding the behavior of the graph of a function, okay, and we have for number 60. Okay, now we have a function g of x, and upon first glance this looks almost like the function in number 59. Okay, at least since we have two terms, but if you look closely, okay, we now have, instead of a third order function, we now have a fifth order function. So you have g of x is equal to x to the fifth minus 2 times x to the fourth. Okay. All right, and so again we have with the leading coefficient, okay, that is going to be at 1. So you had that bit of history to repeat. So you have a of n is equal to 1. So a of n is positive, and with x to the fifth as the highest order term, okay, the degree to which the variable raised, okay, defines the degree of the polynomial function. So you have n is equal to 5, okay, so that is an odd value, and so we're going to have the same end behavior in 60 as we did with 59. So you have down to the left and up to the right. Okay. Then now for the factored form. Okay. All right. So we're going to have a power in x factored out. Okay. And it looks like that for what we're going to have between the two terms. Okay, so we have x to the fifth minus 2 times x to the fourth. Okay, and for the greatest common factor, okay, that is going to be x to the fourth. So in taking what we have here, okay, and I'm just going to stress the degrees again. Okay, so you have x to the fourth. You have times the quantity of x minus 2. X minus 2 will not be to any elevated power. Okay, so that's just going to be to the first. Okay, so you want to have, in the case of the zeros and their multiplicities. Okay, so you have from x, okay, we have x is equal to 0. And from x minus 2, okay, so I have that x is equal to 2. And regarding the multiplicity, okay, so 0 stems from x, which is raised to the fourth, so the multiplicity is 4. And we have x equals 2 stems from x minus 2, so that's going to be to the first power. And in terms of crossing or touching the x-axis, okay, so for what we have here, okay, so you have an even multiplicity. So this will touch at x is equal to 0. And since 2 has an odd valued multiplicity, okay, so the graph of the function is going to cross at x is equal to 2. And we'll have a little bit of history to repeat once again with the y-intercept. Okay, so again, for the y-intercept, you're looking at solving for y as x is set to 0, so we have y is going to be equal to g of 0. So you have 0 to the fifth minus 2 times 0 to the fourth. Okay, so that will go to 0. So your y-intercept, you'll have at y is equal to 0. And again, we have in coordinate fashion, we're going to end up at the origin. And just looking at what we have in the overall view. Okay, so you have x equal to 0 and x equal to 2. Okay, and it's with the respective locations. Okay, so again at 0 it's going to touch, and at 2 it's going to cross. And again, we have with the end behavior, have down to the left and up to the right. And just looking at what we have for the rest of the activity regarding this function g of x. Okay, so we have, starting from the left, okay, so we have this function beneath the x-axis, so it's going to rise, and once we get to the origin, it's going to touch. and go below, and then it's going to rise up again, and once we get x is equal to 2, it's going to cross, and for the rest of the function, this graph, okay, it's going to move up and to the right continuously. Okay, so again, this will be kind of a pattern like what we had in the case of number 59. Okay, now there'll be a little bit of a change up in the crossover to what we have in number 64. Okay, and now where numbers 59 and 60 were odd powered functions, we're now going to have an even powered function with h of x. And for h of x, okay, now this is given as a trinomial, okay, where we have x to the fourth minus x cubed minus 6x squared. Okay. Now I'll just stress the leading coefficient once again. So x to the fourth coefficient is going to be 1. Okay, so you have a of n is equal to 1 once again. So this is going to be positive. And this time for the leading term, okay, the degree is equal to 4. Okay, and for polynomials where the leading coefficient is positive and where the degree is even, okay, we're going to have for the end behavior, it's going to be the same at both ends. Okay, so we just have where a of n is positive, where n is even. Okay, your end behavior will be up to the left and up to the right. Okay, so moving up at both ends. Again, kind of like a quadratic function, if a is positive, then the graph opens up from the vertex where the left and right half are opening upward. And in terms of what we have looking for the zeros, namely the x and the y intercepts. So just going back to what we have with this fourth order polynomial. And again, we're going to have the greatest common factor, okay, to be an x term, and this is going to be at x squared. And upon factoring out x squared, so we have factored out also, we have x squared minus x minus 6. And then for the complete factorization, okay, so we have h of x is equal to x, and I'll just stress the degrees here, so you have x to the second, and we have times the quantity, so we have x plus 2, and this will be to the first, and for the other factor we'll have x minus 3. This will also be a first order. Okay, so for the zeros and their multiplicity, okay, so from just the x factor, okay, we have x equal to 0. From x plus 2, I have x equal to negative 2. And from x minus 3, okay, so I have x is equal to 3. Okay, now for the multiplicities, so 0 stems from x, which is raised to the second. And it's going to be at that location, okay, that the graph will touch at x equal to 0. And we have with x equal to negative 2. This stems from x plus 2, okay, which is just to the first power. So the graph will cross at x equal to negative 2. And for x equals 3, this stems from x minus 3, which is also a first order. So you have an odd multiplicity value. So the graph is going to cross at x is equal to 3. And for what we have in the case of the y-intercept, so you're going to have, when x is set to 0, so you have y is equal to h of 0. So you have 0 to the 4th minus 0 to the 3rd minus 6 times the square of 0. And all of these terms are going to be negligible. So you have, again, have y is equal to 0. And the y-intercept will again be centered at the origin. Okay, so we have for the makeup of the graph for this function, okay, so we have 3 distinct zeros. Okay, so you have at -2, you have at the origin 0, and also we have at x is equal to 3. And again, just for the end behavior, have up to the left and up to the right. So we can project those from the extreme left and extreme right zeros. So we have up to the left. And we have the extreme to the right 0. We have a 3 from this. You have up to the right. And we have just for the activity, okay, so x equals -2, okay, we have the graph is going to cross, and at x equals 0 it is going to touch, and at x equals 3 is going to cross. So we have for the activity, okay, so starting from the left, okay, have above the x-axis, and once we get to -2 it's going to cross to below. Once we get to 0, okay, the graph is going to touch, so it's going to start from approaching, okay, the x-axis, and it's going to bounce off and be below. But once we get to where it's going to ascend and we have approaching x is equal to 3, the graph is going to cross, and the rest of the graph of this function is going to be running continuously up and out to the right. So this will be the pattern to which this particular function h of x is going to be running. All right, and now looking at now what we have so far. Now we've had exclusively the y-intercept, okay, to be the origin, and now we're going to have a bit of a change up in the case of number 72, and in this one, okay, you have we have another h of x, okay, and this is going to be an entirely different expression in comparison to 64. Okay, for what we're going to have now, okay, h of x is going to be the negative of x to the 4th plus 10x squared minus 9. All right, so we have for this one, okay, so you could just kind of regard this, kind of use a little bit of color coding here. So you have -1x to the 4th plus 10x squared minus 9, just to stress the leading coefficient. Okay, so here we have a of n is equal to -1. So this is going to be negative, okay, and we have for the value of n, okay, so the highest degree term is 4th order in x. All right, now we have a negative leading coefficient, and the order or the degree of the function is even. Okay, so you've got a negative leading coefficient for an even-powered function. And we have for the end behavior, this will be moving down both to the left and to the right. Okay, so again we have down to the left and down to the right. And in the case of what we have for the function, now crossing over to what we have in factoring. So we have negative x to the fourth plus 10x squared minus 9. And say if I factor out negative 1, just be able to factor out where the positive term, where I'm going to have a positive leading term. So if I factor out negative 1, so we have x to the fourth minus 10x squared plus 9. Same with h of x. Okay, so with x to the fourth minus 10x squared plus 9. From x to the fourth, we'll have x squared and x squared. And factors of 9 that will add or subtract to negative 10. We're going to have both of these factors will be negatives. We're going to have x squared minus 9 and x squared minus 1. And we have differences of squares with both of these factors. So I can expand further. So we have negative 1 from x squared minus 9. And we'll have x plus 3 and x minus 3. And for x squared minus 1, and we'll have x plus and x minus 1. Notice that you do not have any raised powers for these. Okay, so each of these factors you would read as being of first degree. So in the case of what we have regarding the zeros and the multiplicities and whether the graph will cross or touch the x-axis. Okay, so we have with the zeros. Okay, so our x factors, or factors in the variable x, we have from x plus 3. So we have x is equal to negative 3. From x minus 3, I have x is equal to 3. From x plus 1, I have x equal to negative 1. And from x minus 1, I have x is equal to 1. And all of their multiplicities will be 1. Okay, and since all the multiplicities are identical and the value is odd, it's going to be that at all of these zeros, you're going to have to cross. So it's going to cross at all of these. Cross at x equals negative 3, 3, negative 1, and 1. So you have nothing but crossing the x-axis. And in terms of what we have for the y-intercept, so here we're going to have y is equal to h of 0. So you're going to have like the negative of 0 to the fourth plus 10 times 0 squared minus 9. And just moving down, okay, so you're going to have 0, 0 squared is 0. And the only non-negligible term is going to be the constant at the end. So for the y-intercept, okay, we're going to have a y is equal to 9. and an ordered pair of terms. Okay, so we're going to have it 0, -9. Okay, so we have just for the key locations. Okay, so we have a y-intercept, okay, at 0, -9. And for the x-intercepts, and it's going to be that at all of them, okay, we'll have these to cross. And again, in terms of illustrating, okay, so you have leftmost 0 we have at -3, and the rightmost we have at +3. And you can just project out the end behavior. Okay, so again we have down to the left and down to the right. Okay, so reading from left to right. Okay, so as we get to -3, the graph is going to cross. Then when we get to -1, the graph descends and is going to cross. And in fact, once we get to x is equal to 0, okay, it's going to come to contact with the y-intercept is 0, -9. Then it's going to rise and cross the x-axis at x is equal to 1. Then it's going to descend. And so this is going to be the pattern of what is going to occur for this particular function h of x. Okay, so again the end behavior is down to the left, down to the right, and at all 4 of the zeros it is going to cross the x-axis. And among the intercepts, you have included the y-intercept, okay, which is now away from the origin, and where the location is at y is equal to -9. Okay, now in the case of kind of going back to what we had like the other day, and just want to stress some items here. And now we looked at kind of like taking the FOIL box approach and all that, from where we had determining polynomials from given zeros and multiplicities, and give some cases here, but where the zeros will not necessarily be integer values. Okay, and say that from what we have here. Okay, so determining polynomials so we have from given zeros and multiplicities. Okay, so you have in continuation, okay, just a couple of items here. Okay, so if we're looking at determining f of x, and we just say we have an expanded form, Let's say we have in the first case, all right, so we have with zeros. Let's say we have x is equal to 0. And we'll say that we have the multiplicity to be at 3. And we'll say also we have that x is equal to -4 with a multiplicity of 2. And the degree is just going to be the sum of the multiplicities. So you have a 5th order polynomial. Okay, now looking at what we have and starting out. Okay, so with x equals 0, we say this stems from x. We say with x equals -4, we can say that this will stem from x plus 4. Now, including the multiplicities. Okay, so we have with the multiplicity of 3 for 0, we have the factor will be not just x, but x to the 3rd. And since -4 has a multiplicity of 2, the corresponding factor x plus 4 is going to be raised to the 2nd. And in terms of taking what we have and expanding on out, so you have f of x. And you could go ahead and square out x plus 4, or you could just write this in terms of multiplication. In other words, if you took it like x cubed times the quantity of x squared plus 8x plus 16, okay, that is also correct. But I'll just work this in order from left to right. Okay, so we have x cubed times x plus 4. So this would be x to the 4th plus 4x cubed. And then multiplying by the other x plus 4. And we have with taking the FOIL. Okay, so x to the 4th times x. So this is going to be at x to the 5th. And you have plus 4x to the 4th. Inside product is also 4x to the 4th. And 4x cubed times 4, so this is going to be 16x cubed. So you have x to the 5th plus 8x to the 4th plus 16x cubed. And this will be an expanded form of what we have with the polynomial that has those zeros and degree as described. So we have a 5th order expression. And again, if I were to set this equal to 0, I would end up with this factored form from which I would have these particular zeros and their corresponding multiplicity. Now, okay, so this is a case where we have, again, assigned integer values for the zeros as well as multiplicities. And now, let's say that if I have a set of non-integer zeros, and we'll say we have, first of all, and we'll just keep these to a multiplicity of 1. And we'll say we have x is equal to -2/3. And we'll have another 0, which we will have at 4/5. Okay. Now, if you're to take what we have here, okay, so you have with x equals -2/3. Okay, you could start out with x plus 2/3. And for x equals 4/5, you see we have x minus 4/5. And I'll show you just a couple of options here. Okay, say that you don't care to work with fractions. I'll show you just Okay, say that so if you want to take care of fractions, what you can do, okay, is that you can undo the thirds, and in fact, it's not going to change the nature of the zeros. And what you can do is that for x plus 2/3, okay, we have thirds involved, so you can multiply this first binomial by 3. And for x minus 4/5, you can multiply this second expression by 5. And if I take this approach, okay, so you have with f of x, if I multiply the first factor by 3, I'm going to have a change up. So you have 3 over x plus 2/3. This will be 3x plus 2. Notice, if I were to set 3x plus 2 equal to 0, 3x is equal to negative 2 divided by 3, I still come out to x is equal to negative 2/3. And if I multiply x minus 4/5 by 5, I'm going to have 5x minus 4. Again, like 5x minus 4 is equal to 0, x still comes out to 4/5. And if I take the FOIL on this one, so you got 3x times 5x, this will make 15x squared. And we have minus 12x, and 2 times 5x, so this will be plus 10x. And 2 times negative 4 is negative 8. So we have one version of a polynomial that had those zeros and will be of second order. We have 15x squared minus 2x minus 8. And this is a version if you were to eliminate the fractions altogether. So if you were to set this trinomial to 0, you'll still have x equal to negative 2/3 and x equal to 4/5 as the solutions. Now, if you keep the fractions, okay, so if I have that fractions are kept, I mean, I like to undo fractions, but if you were to keep them, okay, we have x squared, we have minus 4/5 of x, and we have plus 2/3 of x, and 2/3 times negative 4/5, this is going to be negative 8/15. Okay, so I have x squared. Okay, and I'm just going to mention now for negative 4/5 of x plus 2/3 of x. Now the least common denominator for both of these will be 15. So negative 4/5 will be negative 12/15. 2/3 will be 10/15, and negative 12/15 plus 10/15. Okay, so that's going to be minus 2/15 of x. And we have minus 8/15. Okay, and this is also a correct answer. And if you notice, okay, the difference between this result and what I just attained, it's just a factor of 15. If I multiply this expression by 15, which I had done collectively by multiplying 3 and 5, so it'll come out to 15x squared minus 2x minus 8. So both of these answers are correct, for they will have the exact same zeros. All right, and we'll have encounters with polynomials where we have zeros of all kinds, both integers and non-integers. And now, just a bit of set of items we're looking into for the next portion, and this is going to be what we have regarding division of polynomials. Okay. And for what we have concerning polynomial division. Okay. Now, there is one version, okay, and it's going to be long division, and we'll look into just a couple of cases here. And there's going to be another approach, okay, that you can use that might save you some steps. Say if I have something like x squared plus 4x plus 9, and I have division by the binomial x minus 2. Okay. Now as a ratio for what you would have, you have x squared plus 4x plus 9. Divided by x minus 2. Now, with what is regarded as the long division approach, so here I'm looking at taking x minus 2 into x squared plus 4x plus 9. Okay, so I got both. Okay, now what I have here with x minus 2, this is what is called the divisor, what I'm taking into. Okay, and then what is taken into, okay, is going to be the dividend, which we have at x squared plus 4x plus 9. And how much the divisor goes into the dividend is going to be the quotient. So if I look at the first terms from both of these, so I have x and x squared, and if I were to multiply x and x squared, or divide x squared by x, now the leading term is going to be at x. So we're going to have along each stage, just to give you a little bit of a cue here. So you have x times x minus 2, x over x minus 2. Okay, so this is going to be x squared minus 2x. Okay, so looking at what we have in the activity, if I distribute x over x minus 2, say x over x becomes x squared, x over negative 2 becomes negative 2x. And with long division, I'm looking at row by row subtracting. And the object is going to be to take the first term from the dividend portion at each stage and cancel. Okay, so we have, so if I look at distributing subtraction, so if I distribute subtraction, so I have x squared minus x squared, this is going to go out. Now I have 4x minus negative 2x, so this will be 4x plus 2x. So that'll be 6x, and then x, this one, say have x squares go out, 4x plus 2x will be 6x, and then we can bring down the positive 9. Alright, so at this stage, from the dividend cancellation, okay, so I have 6x is now the leading term, and now x will go into 6x 6 times. So it'll be positive 6 times. And just say, just for distributing, so you have 6 over x minus 2 So this will be 6x minus 12. And this is what's going to be situated beneath 6x plus 9. So we have 6 over x minus 2. So we have 6x minus 12. And we have another round of eliminating. So subtracting. So 6x's will go out. Now we have 9 minus negative 12 will be 9 plus 12. So this will be at 21. And I can no longer take x. I can no longer continue. So I cannot take x directly into 21. And just for the characteristics that I have here, just for the terms. Now again, the divisor, again, that is x minus 2. And the dividend, okay, this is what is taken into, so you have x squared plus 4x plus 9. Okay, and we have for x plus 6, okay, this is going to be the quotient. And the number 21 here, that is going to end up as the remainder. Okay, so x minus 2 to x squared plus 4x plus 9. Okay, that is going to go x plus 6 times, but leave a remainder of 21. Okay, and let's say that, just a separate case here, if I have so you have x to the 5th plus 4x squared plus 5 is divided by x plus 1. Okay, so just setting up what we have here. So here, x plus 1 is going to be the divisor. Okay, now for the dividend, okay, notice there's a gap between the degrees. Okay, so we got x to the 5th. Notice we do not have an x to the 4th term. So what we want to do here is use zeros for placeholders. So we got a missing 4th order term. We also have a missing 3rd order term. Now we do have 4x squared. Notice we do not have a 1st order x term, so we'll use 0x, and you want your polynomial to end with a constant. So we have a plus 5 in this setup. So looking for the quotient, if I take x, x is the first term in the divisor, x to the 5th is the first term in the dividend. So the first term in the quotient will be x to the 5th divided by x. So this will be x to the 4th. I'm just kind of showing, so you have x to the 4th times the quantity of x plus 1. So this would be x to the 5th plus x to the 4th. And so just carrying over what we have here. So you have x to the 5th plus x to the 4th. And taking what we have in subtraction, so x to the 5th will go out. Then we've got a minus x to the 4th. And we can bring down the rest of the terms. Okay, we have next in line x will go into the negative of x to the 4th. So this will be minus x cubed times. And distributing negative x cubed over x, so I have negative x to the 4th. Negative x cubed over 1 is going to be a minus x cubed. And we now have with distributing subtraction. Okay, so negative x to the fourth plus x to the fourth will cancel. Now we got 0x cubed and what's going to be plus x cubed, so this will be x cubed. And bring down the rest, so you have plus 4x squared. You have plus 0x. And again, the 0x is for placeholder purposes. Now we have the next go round, we have x into x cubed will go x squared times. And distributing x squared over x becomes x cubed. X squared over 1 becomes x squared. And distributing subtraction, so we're going to have x cubed minus x cubed. 4x squared minus x squared will leave us with 3x squared. We have plus 0x plus 5. Now for the next go round, okay, we have x will go into 3x squared. So you got 3x times. So you have 3x squared plus 3x. And distributing subtraction, so 3x squares will go out. And we've got 0 minus 3x. So we've got negative 3x plus 5. And x will go into negative 3x, negative 3 times. So you have negative 3x minus 3. And for the, since you're leading up to the final stages here, so negative 3x plus 3x goes out. 5 minus negative 3 becomes positive 8. And so we're going to have, with the quotients, be the set of terms in the top line here. So we have x to the fourth minus x cubed plus x squared plus 3x minus 3. And I cannot take x plus 1 into 8, and 8 is going to be the remainder.